Hello everyone. Today we'll be talking about how to store n-dimensional data in R, which is just data that doesn't fit neatly into a two-dimensional matrix or data frame or even a one-dimensional vector. So just data that's too complex to fit into a neat grid like that. For this we will use lists, which is the R data type that are used to store n-dimensional data. And to illustrate an example of when you might need something like this, let's imagine a scenario where you have a series of pictures taken at different time points. And these are black and white pictures. So to represent the data from these pictures, we're going to say picture 1. So picture from time point 1 is going to be a matrix. We'll say it's a completely gray picture because I don't feel like coming up with a whole bunch of random pixel values right now. I will say it has 100 pixels by 100 pixels. So 100 rows by 100 columns in our matrix. I see that gives us a matrix with each pixel value at 0.5. Okay, we can now do this. These are all the same, but we'll just make distinct objects to make the illustration a little clearer. So picture 1, picture 2, picture 3. And let's say we want to find a way to store all of these in a single R object, because you can imagine a scenario where maybe you would have hundreds of time points, or maybe you have thousands of frames from a movie or something like that. And you don't want hundreds or thousands of matrices cluttering up your R environment. You would really like to be able to store everything in a single object. We can do that with list. So my list is the object name we're going to do, and we'll use the list function for this. And it's as simple as doing picture 1 followed by comma, picture 2 followed by comma, and picture 3. Now all of those lists are in one object called myList. You'll see that there are 3 matrices here. So let's talk about how to access the data. So accessing data from a list. So if you remember, with a vector, you index with square brackets and then numbers or a vector of numbers to pull out whichever element you want from that one-dimensional vector. And then with a matrix or a data frame, you now have 2 indices you need to provide, a rows index and a column index. So you might think that myList would just add a third element, right? So let's say you first pick the element you want, and then you pick, the rows and columns from that element. So if I just run this, you'll see that indeed that is not the case. It's a little bit different, and the way it's different is instead of using a single square bracket, you're going to use a double square bracket. So now if I want the first matrix in there, I do double square bracket 1, and that is my first matrix. And perhaps to make this illustration a bit more obvious, let's actually change the values so that they're not all the same. And now you can see this first element is indeed that first matrix. If I do the second element, now this is my second matrix, which now has values of 0.6. And if I do a third index, that is my third matrix. Okay, so what if I want to then use this matrix and subset this matrix? Well, remember, a matrix can be subset with single square brackets, and we can just add those at the end of our list call here. So let's say we want the first row and all columns. So we'll do a 1 in the row index and a blank for the column index. Again, that means all columns. And you'll see that we've pulled out 100 0.7s, which is just this first entire row of the picture 3 matrix. Okay, so I hope that makes sense. It's relatively simple. Essentially, you pull out the element of the list that you want using double square brackets, and then you pull out, and then you can index whatever that is normally as you would by adding on that index to the end. So if, let's say we have a vector here, and we'll just do the vector 1 to 10. I can add that into my list as well. The list does not care if its elements are the same or different. And now, if I do my list 4, you'll see we've pulled out a vector, and if I want the 5th element of that vector, I just do square bracket 5, and I have pulled out the 5. I hope that makes sense. Let's talk a little bit about names in lists as well. So here I haven't put any names with my list, but I certainly can. So if I take and make a second list, and we'll call it my list with names, I could do picture1 equals, essentially naming the first element of the list picture1, and this could be picture2. And for clarity, I could say, random name. It doesn't matter what your name is, it can be anything. And we'll just say vector. So now I have another list. And you'll notice now, before we had these dollar signs over here with nothing after that because there were no names. Now we see the name of each element of our list. And because we have named them, if we don't feel like using the square brackets, we can now my list with names. We can now use a dollar sign to pull out each element of a list, much like we would do with a data frame, except now instead of pulling out a column, we're pulling out an element of the list. I hope that makes sense. So the last thing to talk about with lists is the difference between single and double square brackets. So before I said you don't just use the single square brackets, with 3 elements or whatever. You can still use single square brackets. You just get slightly different results. So if I do my list single square bracket 1, and let's just clear the terminal. So do Control L for that. And let's actually do 4 so it fits nicely here and we can see. You'll see that we have returned the first element of the list, but you'll see this double bracket 1 here. And what that means is that this function call is returning a list. So if I just do temp, store that value, you'll see that temp is a list of 1, which means if I then try to do 1 here, so much like, well, I guess we'll just make it the same here. So here I did my list, double bracket 4, single bracket 5. So let's do single bracket 4, single bracket 5, and see what our result is. You'll see that it's null, which isn't what you expect. So what's going on here? What's going on here is that when you use the single bracket, it is a list. So if you do another single bracket, it's now looking for the 5th element of that list. And this is a list of 1, so there is no 5th element, so it's just returning null. By comparison, if we do my list double bracket 4, we see that we now have the vector here, but there's no double bracket, which means that whereas this top one is returning a list, this one is just pulling out that 4th element entirely as a vector. And the reason why you would want to do the single bracket is you could do C, so to feed in a vector here, 1, 2, 4, and now you have a list of 3. So we've essentially omitted the 3rd element of our original list. If we do that here, or try to do that, it's not going to work because with this double bracket we're saying we want 1 element no longer in a list at all, and R doesn't know how to handle multiple indices here. Okay, so I hope that makes sense. So maybe I'll just add some comments to make it clear. Returns data as a list. Returns data as whatever data type that element of the list is, in this case, a vector. Okay, and just one last thing to mention, you can store lists inside lists if you want. So really the list is a very flexible data type that can store basically any type of data you can think to throw at it. All right, so now that we've talked about vectors and matrices and data frames and lists, you know about all of the major data types in R, which means in the next video we'll start talking about how to import your own data into R so that you can work with it without having to manually construct these data objects yourself.